Hello students, we're going to go through a little bit about work. I do have slides, they are attached to your K-mail. So let's figure out what we already know. Energy is the ability to do work and it requires force and distance. What do we know? We know about force and we know about distance. Now, make sure by the end of the lesson you can write a definition of work and describe work using an example. Describe it in your own words using an example. Make sure that you understand the difference between work and energy, okay? So let's look at things we already know. We know about force. We know force is mass times acceleration. We know about acceleration. We know acceleration is velocity 2 minus velocity 1 divided by time. We know about velocity. We know velocity is distance divided by time in a certain direction. We know about potential energy, stored energy or energy that can be used. We know about kinetic energy, energy that is being used, energy in motion. But we don't know about work yet. What we need to do is take all of this information and put it together, and then we'll know about work. So what do we know? We know that you use energy when you do work. There are two kinds of energy, potential and kinetic. We know that. What's our main idea? Types of energy are the main idea here. There are two types, kinetic and potential, and you should be able to write the definitions of those. You should be able to put examples of each and the formulas of each. What else do you know? You know about force. You already know about force. You know force is mass times acceleration. You know about displacement. Maybe you haven't called it displacement before, but displacement is actually the distance an object moved. So you do know about displacement, but you've always called it distance instead. So displacement is really just how far, and you measure it in meters. Work is our main idea. Work is how much force, how much push or pull, how strong is the push or pull, and how far did the object move because of that push or pull. Now here's a guy with a box. You should be able to take this example and put it in your own words down here, right? This guy has a box. How heavy the box is, right? How much force is required to lift that box? So in other words, you're lifting it against gravity. So we're doing work against gravity. So the amount of force required to lift that box against gravity and how high you lifted the box. How far is it to the floor? Did he lift it about 3 feet? We should call that 1 meter, right? Those two items will affect the amount of work done. So work is equal to force times distance. All right, so our main idea is work. All right, our main idea is work. The formula for work is force times distance. So it's just another math problem, right? You should understand that the units of work is called a joule. When you take the units of force, which is a Newton, times the unit of distance, which is a meter, you get a Newton meter. Well, a Newton meter is kind of awkward to say, and it's kind of a mouthful to say every time you want to say work. Joule is a lot easier. So a Newton meter and a joule are the same thing, but when we talk about work, we always want to say joule. Okay. So then you have to take this example of the box, the guys in the box, and you put it in your own words, right? When you talk about the amount of work done here, though, I think this is actually a piano. When you talk about the amount of work done, you're actually talking about the distance straight up from the ground because this is work against gravity. Work against gravity. Gravity goes straight up and down. So how high this is lifted straight up from the ground is the distance, and then the amount of force needed to move it would give you the work. And so you would describe that in your own words. There's no numbers, so just do it in words. And then right in here is where it tells you that work is measured in joules. And right down here. Okay. So you do work when you lift an object. I'm going to let you do the main ideas, the details, and the problems here. So the work done when you're lifting an object. So maybe your main idea here is the amount of work. And the details would be work against gravity. Work against gravity has to go straight up and down. I would add that. Work against gravity has to go straight up and down because gravity pulls down. You can do work by pulling an object up, or work can be done by gravity by making an object fall down. Here is your example. And if you go into the lesson and you do this example, it will do the math for you. But it's taking a 1 kilogram rock, which is pulled by gravity, and we know things fall with an acceleration of 9.8 meters per second squared because of gravity. So it's going to be working with a force of 1 Newton. All right, so don't worry about really how we get to that. Just know it's falling with a force of 1 Newton. If you lift the rock 1 entire meter, that means the bottom of the rock is on this line. All right, then it's the force of gravity, 9.8 newtons, times 1 meter, and what do you get? 9.8 joules. You need to put that down here under examples. Okay. Now the difference is, when we're talking about work against gravity, remember I said things have to go straight up and down? So your main idea here is work against gravity, and your detail is objects have to go straight up or down for work to be done, but objects that go side to side, no work is done by gravity. When objects go side to side, no work is done by gravity. That's very important. So in the lesson, you can actually grab this little red thing and you can pull it back and forth and the rock will move back and forth. And notice these numbers don't change because gravity is not doing any work, and you are not doing any work against gravity because gravity can only go up and down. If your rock goes side to side, it's perpendicular and no work is done. So just so you know, this would be maybe some details that you could write down here, right? And so if the rock is moving, you know, because there's movement, there's some work. So where does that work come into play? And that's when you have to talk about friction on these pulleys. There's a little bit of friction on the pulleys. Because there's a little bit of friction on the pulleys when the rock goes side to side, you're doing a little bit of work against friction. But because it's going side to side, there's no work against gravity, which is only up or down. So again, you're going to want to put in your own words this example. So this is the same exact idea as the rock going side to side, but now it's talking about potential and kinetic energy instead. So you're going to want to, over in your main idea, work against gravity. In your details, you're going to want to talk about potential and kinetic energy. And if you're talking about gravity, if that hockey puck cannot fall, it's sitting on the ice, whether it's moving or not, it doesn't matter. If it's sitting on the ice, there is no potential to fall. Zero potential energy, zero kinetic energy, zero work. Got it? If the hockey puck is lifted into the air, then work can be done because it can fall back down again, right? This is work against gravity. If you want to say, yeah, but the hockey puck moved, well, it did. And there is some friction, right? So there is some work against friction, but it's only a little bit. All right? So now we've got 3 elements are necessary for there to be work. Main idea. Details. What are the 3 things necessary for work? Force. So you got to have a push or a pull. Displacement. It's got to move somewhere. Got to have a distance. And there has to be something causing the displacement. This truck is causing the snow to move. If it goes up or down, you're doing work against gravity. If it goes side to side, you're doing work against friction. Make sure you understand the difference. Okay. Work can be positive or negative. Work can be positive or negative. There's your main idea. You want to know what positive work is and negative work is. Positive work goes in the same direction as the push or the pull. So if you pull an object and you're moving backwards and that object is going with you, it's positive. If you are pulling an object like on a pulley and it goes in the opposite direction, it's negative work. So if you think about this, the guy is pushing the mower and the guy and the mower are going in the same direction, positive work. But he's pushing against the ground, so there's friction, right? So if there's friction, if the guy is pushing against the ground and friction is pushing against the guy, right? The one that's going in the same direction as the guy is the positive work, and the one that's going in the opposite direction of the guy is the negative work, right? So friction goes backwards, friction is negative work. Him going forward with the mower is positive work. Same thing, same exact thing with these guys. These guys are pushing, and the guy pushing and the object both go to the right. Friction goes in the opposite direction to the left. So the guy and the object are positive work. Friction is negative work because it's going in the opposite direction. All right, so there is your example. All right, heat energy can do work. Main idea, right? How exactly does that happen? Well, you've got a closed system because it has a lid on it. This is a piston, and it's sitting there with a 5-gram weight on top. Heat the water. We know hot things rise, cold things fall. When you heat the water in a closed system, we also know that the molecules move faster. And when the molecules move faster, right, they spread out. When those molecules spread out, they spread out in all directions. They spread out in all directions. So I'm going to flip that one around. They spread out in all directions with the equal amount of force. Whoop. Meant to grab the little arrow here, right? They spread out in all directions. And when that happens, what do you think happens to the piston? It gets pushed up. Well, guess what? Gravity pulls down, the piston gets pushed up. And so they're in opposite directions, so it's negative work, right? Right? Okay. And now work is done because that piston moved from the bottom right here up to this point there, so that when a small distance, it's a small mass, so a small amount of work was done. But using heat energy can cause work to happen. So you're going to want to put this example in here in your own words, right? And here is your detail. Heat energy can be used to make matter move. If matter moves, work is done, right? Okay. So energy, work, and force are all related. Main idea. Work involves force, cause, and displacement. Here is a detail. Yes? There's a detail. Force, cause, and displacement. All right. So and then it gives you an example. Examples include picking up stacks of books, throwing a shot put. You can calculate work. Here's another detail. You can calculate work by multiplying force times distance. Okay? You can calculate work. Those are details that you can put down here. You can put those details down here. And then you can put some examples down here. It also talks about positive and negative work, right? Positive and negative work. And those are more details. You can put those down in the details part. Let me make that arrow just a little shorter. There we go. You can put those details down there, right? Okay. So those are details that you can include in your notes. And then you can put some examples that we learned about right here. Now, you should do this activity on your own. What do you know now about work and force and energy? Can you define each? So you need to be able to define work, force, energy. And you should be able to give examples of each, right? Work, force,